Morning, Singapore. Okay. My topic is about how to bootstrap a live streaming React web app. I think this year's JS conference is perfect, and I just saw the 5-minute talk just then, and I think there is a very tiny thing I think is quite considerate. There is a cameraman out there, and then he will switch the video here to show the demo performed by the speaker. And I think I seldom see this behavior in China's conference, so I think it is quite considerate. But I think there is a pity that this year's conference has no live streaming video. So the developers outside Singapore cannot enjoy such a perfect conference. So hopefully next year, the committee of the conference will provide a live streaming video to the developers all over the world.
I agree.
Yep. Okay, we will provide service for you. Okay, about me, I'm from Tencent, AlloyTeam, which is, I think, one of the best front-end developer team in Tencent. And my major focus is on automation, web app, and the performance of web app. And there are a small numbers of apps with live streaming features in China. So you can see the competition in this segmentation is quite fierce in China because everyone wants to catch up this trend. So what comes up in your mind if I mention live streaming? Do you have any ideas? Yep. But there are more scenarios. For example, in university, we usually skip our courses because the professor is so boring. So we will just watch the lecture video after the class. And then some musical students will play the piano to earn money in the live streaming app. And as a gaming fan, we would like to enjoy a gaming narration. Or as a James LeBron fan, I would like to enjoy an NBA sports. But there are a lot of mature native apps out there. But why we need to build another web version of live streaming app? There are two reasons. Number one, we would like to attract traffic. For example, this one is the screenshot from Live.me, which is a famous live streaming app in the USA, which is produced by a Chinese company. And when you think the host of this video is funny, and you click the share button to share the link to the Facebook or Twitter, then when your friends click the link, and they also think the host is quite impressive, they will just register, download the app and register as the user. So that's the target of the web version. Number two, it can be a replacement for some native features, like the live room. And the second one is promotion activities, because there are a lot of different kinds of activities. The users will pay these activities because they will earn some gifts, or they can improve their favorite host in the rank. But it is not good for a native app to build different kinds of activities. So this is the opportunities for web. And in this talk, what I'm going to show you, there are 3 parts. The first one, in case there are some people do not know what live streaming is, I will show you some basic concepts about it. And then after that, I will show you how to design the basic structure of a complete live streaming app. And lastly, is the core of today's topics, is what to build in React. So what is a video? Here is a group of pictures, and they're consecutive. When you play these pictures in a very short time, you can see an animation. So this is a very simple video. But for video, it is not only contains images. It contains like audio and the metadata about this video. And a codec is like a tool to compress the raw data. For example, video, we usually use H.264 to compress our video, and we use AAC or HAAC to compress audio. And after that, we will wrap it into a container. We usually use like MP4, AVI, or FLV. But is there any connections between live streaming and video? Yep, they do. Live streaming is to deliver the video frame by frame from the server to the client. Here is the flow of how live streaming is delivered to the client. Firstly, we use our device to produce the raw data, and then we upload the data via RTMP and WebRTC. Then we can add some watermark or some filters to make the video without defects. And then we compressed the whole thing with codec. And when we finished the compression, we will push the stream using like FLV, RMTP, or HLS. And finally, we get to the client. When the client gets the streaming, they will just play the video right away. Before front and side, we cannot do a lot of things about it, but we can still do something in the last step. I will show you later. So how can we play the video source in the web? We have three kinds of solutions. In old days, Fresh plus FLV is the mainstream. It has low latency. However, since Apple and Google decide to give us supporting Fresh in the future, so video and HLS will be, video tag and HLS will be the future. Though it has high latency, but it has a good compatibility in mobile. But MPEG-Dash, I think, will be the future standard. It not only has low latencies, but it also has back compatibility. And it's also convenient because we can load MPEG-Dash video via HTTP and HTTPS. So what exactly is HLS? It is short for HTTP live streaming. It has a control index file called M3U8, and in this file, it has a list of TS files, which is the video we play in the client side. And then it has H.264 for the video codec, and it has MP3 or AAC for the audio codec. But if you would like to play the HLS in Chrome, you have to install a native LS extension. And when you install it and show the developer tool in Chrome, you can see there is a list of information about the TS files. It includes like the data and the duration. So after a very boring lecture, I'm going to show you how to design the whole picture of the architecture. Before we kick off, we need to think about where the apps will be where our web apps will be shown. Firstly, we usually have a standalone version, and then for some pages, we will show it in the native web. And in order to attract the traffic, we will share the links to QQ or WeChat in China, or in Western countries, we'll share it to Facebook or Twitter. And there are some sophisticated video solutions, like in Tencent Cloud, we have video solutions for those startup companies. And as a startup company developer, you can use the API or the SDK provided by Tencent Cloud, and then you can build a very simple video player. But it is not enough. It is still far away from a complete video, a live streaming app. So based on our working experience, I come up with this map of a whole structure. At the top, we have a user system. We offer a system for the users to register or log in, and we have a charming point and level system. This is quite important because the users will pay to increase their charming points and the level, and that's why we can survive. And next, we will have a room which accommodates a lot of content we provided to the users. And for the video, we have two kinds of videos. We have a live streaming, and the host can deliver the message there or perform things in real time to the clients. And then if they think the content is quite meaningful to the clients, they will just make a record. And then after they finish the live streaming, the clients can take a look at it when they're free. And we also have a message system for the clients to interact with other users or the host. And we call the four parts the content provider, because we think these four systems will provide meaningful content to our users. But besides, we have to survive, so we need to attract users to pay for our service. So we have to build a payment system, a gift system, and an activity system. But to ensure the whole thing working fine, we need a monitor system to monitor the performance and the error rate of the whole system. But you see, it is quite a large-scale system, so it is quite limited. There is not enough time today, so I will just focus on the front-end side in this conference. So what we used to build, I have already mentioned in the first PPT. I will use React to build the whole system, but it's not enough. I will also use Redux to manage our data, and React Router to manage the route. And we also have the help from the Webpack because we need some APIs like require ensure in Webpack version 1 and system.import in Webpack version 2 to make sure that we can build a single page application. But to ensure stability of the whole system, we have to use the starter kit. In July, Facebook has already launched a starter kit called Create React App. But when I use it, I think it is good, but it is not enough because it only gives us a Hello World project. So I just decided to create a starter kit called Steamer React. This is also a starter kit, but it is based on our team's best practice and how we improve the performance of React. For example, we include pure render features in this starter kit to ensure that we can improve the data comparison process in React Web. And we have a touch event component to solve the problem that React does not support touch event in mobile browser. And we also have a Redux dev tools to help the developers to see the data flow when they develop the app. And in addition, we have 3 template choices. For the first branch, we have a simple branch. It is just a Hello World project, just like create a React app. And we also have a React branch. I use Tencent News web app as an example. So as a developer, when you use this starter kit, you can just copy the code from these demos. So it is quite an easy process to develop an app using this starter kit. And lastly, I also include isomorphic feature in this starter kit. So if you would like to boost your performance, you can use this branch. And in the future, I may also build like Steamer Gap, Steamer Vue, and Steamer Angular, and so on. So you can choose whatever frameworks you like based on your project. For today, I will have 2 cases to show you. Case 1 is the live room. And there are several pages. For the first one, it's the list page, which has the recommended host in this app. And for the second one is the setting. And the last one is the live room. And this one is the profile card in the live room. And I will show the demo here. I write this demo for the past 3 weeks right after work. And here's the list page. And then I click it. And now it plays Game of Thrones. And then I can chat with the anchor. I can send a GIF to the anchors. Oh, there's a bug. And after this conference, when I clean up the code, I will just put it in the GitHub. And hopefully it can help you to build a live streaming app for your company. So our target is to build an SPA. Let's do a division job first because React is a component-based framework. So we need to divide the whole app into pieces. So in the red frame is the video component. And the green one is the message component. And the blue one is the activity component. The yellow one is the gift and payment component. The red one will be the user component. So as a whole, they compose a room component. And it's quite clear that the code structure will be like this. So before you create an app, you can just create some empty components first, and then you place video, chat, footer, and so on in this structure, in this wrapper. And after that, you can just fulfill the content of each component one by one. So let's come to the most important part of video. We have 2 kinds of video components, as I mentioned before. We have a live one and a playback one. And clearly, the live one is the subset of playback. So let's finish the more complex one first. Let's do the division job again. Here is the progress bar, the play button, the TikTok, the audio button, the audio controller, and as a whole, it is the controller. And right above it, it is the component to show the video. So for the bottoms, which has not so much change, we can use a cons element in React to represent. And we can, and all these cons elements can composite a playback control. So we can create another component to accommodate these elements and write some logics about how to control the video. And since we know live control is the subset of playback control, we can just simply extend it, and then we can just do some small modification. For example, we know a live controller does not contain a progress bar. We do not need to initiate the progress bar in this component. And then we use live control playback and video text to form the whole live room. And in this process, we use HOC to help us to finish the job. So what is HOC? It is short for high order component. I think it is quite easy for you to understand. It is just like you put a Pikachu, and then it returns a Rachel. Yeah, it always returns a stronger one. And then when you try to create a live room or playback room, you just put the video and a controller, and that's it. So here's an example. You just create a playback room creator, which is an HOC, and then you play some metrics in these components, and then that's it. And this is the same here. So in a world, it is just like a template, you might think. If you use HOC correctly, you can just create different templates for whatever the product manager asks you to do. So if the manager hopes to add the bullet screen, you can just put a bullet screen component here, and then you just finish this component. That's it. It's quite easy. Actually, these are the old concepts which you may see in other advanced programming languages. But React is a new implementation of this new concept, and it is a perfect one. For those elements, does not change much. You can just easily use cons element to represent. And for those components have a lot in common, simply use extend. And lastly, if you want to create different combinations, you can use HOC. After some chit-chat, I would also like to show you how to control the video. For live broadcast, it does not take a long time. You can just use M3 UA if you use HLS, and you can place a video tag here and add some logics to listen to the video events like can play, praying, time update, and etc. For playback, it is also easy too, but what if the product manager hopes to support Chrome? And then you may consider to use MP4, but would you still use only one link and one video tag in this scenario? I would say no. I would use 2 or more video tags to help. But the theory is the same as HLS, because in HLS, there are several pieces of TS files, but the browsers will do the whole work for you. It will just play the first TS files, and when it is nearly finished, it will load the second one. Here's the example. We have 3 video tags here, and when the first one is playing, the other 2 are idle. And for example, there is still 10 seconds to go in the first video. You will start loading the second one. And when the first one finished, the second one starts playing. And the whole process loops. And then this theory, I think, is quite clear, right? And here are some compatibility issues on how to control the video, but I will not go into details. You can take a look after the conference. Next, I would show you how to load the stream as fast as I can. There's something front-end side cannot do, but we can help the back-end side. Actually, the size of a GOP really matters in this situation. For example, if the GOP is too big, though it has a high resolution, but there is some downside. The performance of the first screen will be slow, and we have a high delay. So we have to trade off. We have to pick up a relatively small size in an acceptable range of resolution. But there is still something the front-end side can do. In React, we can use server render, which is called isomorphic. And there are 3 options here too. And from left to right, the performance will be worse. For the big pie, it has the best performance. But for the window data as script, it has the worst performance. But it is still slightly better than the app without server render. So what is window data? For example, you create an Express server, and then you just load the CGI, the API, and then you just put the data in the script. And after the server renders the whole structure, the JS in the front end will just get the data from the script, and then it will render the whole structure. However, from the right one is the easiest to implement. For BigPy, you have to do a lot of work, like change the whole structure of your logic, and you have to also modify the building tool to build the app. So for me, I will just use render to stream. It has a relatively better performance, and you don't have to change a lot in your app. You just use the render to stream API in React, and that's it. So after I finish the video part, I will introduce the interacting part in the live room. There are 3 pictures here. For the first one, it shows you the messages. And the second one, it has some faces you can send to the anchor to express your feelings right now. And for the right one, it offers some gifts for you to send to the host if you like this anchor. So there are also 3 choices for you to build this interactive part. We have a WebSocket, which is the future choice, but since it has some compatibility issue and some polyfill, to finish this job is quite large. So I will just dump this choice. But I will take a look at, I will keep watching how the community solve these problems. And if in the future, the browsers, more browsers will support the WebSocket feature, I will turn to this option. For the second one, event source, since it has a one-side communication feature, so it is also not good for building the interactive feature. So lastly, I would choose long polling. It is a cross-browser option. You can just use it. You can just use Ajax to finish this feature, and it does not use up too much server's resources. So it is quite a good choice. One last thing. Don't forget to control the DOM numbers, because when the users send a lot of messages, and the DOM numbers will just increase immediately. So we have to control the numbers to avoid the rendering issues in this app. So the second case is about activity, which is also the important part because we need to rely on this part to survive. We need to attract the users to pay our app. We have different kinds of activities here, like Lucky Draw, gift game, or discount for recharge, and song request. And actually, we can see in the left side, it is the PC version of a Lucky Draw activity. And on the right side, it is a mobile version of Lucky Draw. And there were a lot of components we can reuse. And when we finish the left one, we will just copy the code and do some modification in CSS styles. And we can tackle it using just one developer account. But in this case, what I want to show you is that React is too heavy for this kind of pages. And when I try to recommend React to my colleagues in such kind of activities, they refuse to use it. Why? Because the thing is it is too heavy for activity pages. So I would recommend you Preact in this case. It is a lightweight solution in a community, and it also has a good performance. You can use exactly the same React API and JSX, and the code base of this project is quite small, and our team started to contribute to this project in order to fulfill our target. And here is the benchmark. You can see the performance of this framework is not that bad, and in some tests, it is also better than React. And the most impressive thing is that Preact only has 10 KB, and even you add Preact come back to use the full APIs of React, it only adds 14 KB to the whole bundle. But comparing to Preact, if you use React, it occupies more than 100 KB, and that's quite a lot. And here is the list of...
It would be good if you can wrap up in the next 2 minutes.
Sorry?
It would be good if you can wrap up in the next 2 minutes.
Yep, yes, I need finished. And here's the list of lightweight solutions. And you can take a look at it when you go back home. And yep, this is the end of my topic. And today I have already talked about live stream. This is the content we would like to provide, and we use React to build the whole things. So hopefully, this lecture will tell you how to build the whole thing in like 1 week or 2 weeks. So thank you.
Thank you, Chengxi.